Hello everybody, Brian here from quantlabs.net. Today I want to show you a basic order info or an ordering kind of ticket system, whatever you want to call it, with J4X or the Dukascopy J4X API using the SDK found in this Java sample. Showed many different examples before. So what I've done is I'm going to be using Redis NOSQL database as my backstore on top of my message queuing to drive the commands to open and close orders within the J4X. And the purpose of this is to build a bridge between my Python scripts that I've already developed and the J4X API using Java so I can send out orders. So this is the very basics and the primitive. I'm going to show you the challenges, but I will show you the next steps. So you may want to watch all these videos that I put together here on my YouTube channel. Alright, so the first step is we have the Redis server running. Doesn't matter what version at this point. Also, we've got the Redis CLI right here running. And what we're going to do is we've got an L-push, L-range, as you can see here. And we have a key called order. Now, this has got to be more unique, but I just want to show you the most basics. Just sending in one order, one close, one buy, and then close the position. So here's how it works. So I'm going to send in the commands from the Redis CLI, push it into Redis, and then at the other end in the code here, we will have J4X, the Dukascopy API push those orders through. So we will run this main from this package here called test order Redis in Java in my NetBeans here. And essentially what we got here is all the usual stuff. Hopefully you follow along with the Dukascopy playlist. And what I've built out is a couple of things. First on the ticks. So usually we don't do anything on the on start. In our case, what we're going to do is actually no. What I'm going to do is I'm going to comment this out. This shouldn't be there. So hopefully this will work. Okay, so what we've got here is in my onTick method, what we're going to do is we're going to do a connection, open up to Redis, do the usual way, localhost port 6379, does a list, and then it does a JEDIS on the L range on order. As I said here, in my Redis CLI, we got the order right here. So when I do an L range on the order, we've got an empty set or an empty list, and we're going to start pushing simple little orders through it into using the Java API. So what we got here is we need to keep track of how many nodes have been retrieved from the L range. So we instantiate a integer row count at the beginning. So that's our temporary row count. So we'll retrieve everything using order 0, -1, that's everything. And then what we do is we subtract the size of these nodes that is retrieved minus the last count on row count. And it seems to work okay, and I'll show you the message here so you know what I mean. So if the difference between the rows, the size and the row count is greater than 0, that means that we've got a new order. I'll call it command or whatever you want to call it. And what we do is once we get that, we need to process all of those most recent commands of order or close. So if I rewind or go back historically, what I can do is I can L-push new orders onto the list here. So here in this case we've got 444, open 555, and 553, and then 663. So it's basically last out, well, depends how you look at it, first in, last out, or whatnot. But what we're doing here is, as we're adding and pushing new commands, like here, onto this list, we want to get the most recent one using this methodology, and then process those, and then based upon if it's just a simple open or close, and open or submit the order or close the position. So what we're essentially doing here is, as I said, if there are new commands in the Redis queue, if the order key, what can happen is we will iterate through the different nodes, display the command if it's a open or a close, and if it's an open, submit the order. In this case it's a long. Now here's where the tricky part is the long, the order ID. Now the question is, how do we differentiate each order and sync it up when we want to close it? So that's still a trick that I have to figure out, but I think I might have something where I can put probably a unique timer when the order is created, and then internally in this strategy maintain those orders, and within this class, this Java class, maintain those orders. So if the close comes in to close a certain position, then we'll close it, and then take out that from the internal array that we may keep track of, or list, or whatever it may be, some kind of container. So if it's an order or open, we go in and submit an order to Dukascopy, and if it's a close, we close it. So it's just a simple way of just demonstrating this capability. And once we're done, we reset the row count to the latest number of nodes that we retrieved here in the L range. So essentially this is a simplified system, but as I said, we got to figure a way to keep track of these order labels. And then the actual orders is simple. One instrument in this case, we have our order command, which is basically an open, and then some other little data. And then at the end of the day, we just want to close whatever's in there. Just simple stuff. So I'm going to fire this puppy up. Okay, first, like I said, in the order key, I'm going to make sure it's empty. As you can see, it's empty. Yay. And what I'm going to do is I'm going to fire up this Java program. Don't ask me why it's doing that. Okay, there we go. So it's going to fire it up, do all our logging into the credentials and all that fun stuff. And then what we can do, meantime, let me just get rid of this guy. So you can see everything running in the background. So why don't we just do some pushing on an order? Or not, no, let me just hold off because we want to keep it simple. Okay, so it's still firing up. Starting the strategy now. So you can see here, no orders are on the message queue, so that's why it's coming back as 0 rows. But if I put an order in on order, give it a little time, you can see here each order, or I'm sorry, no, I gotta put open. So there you go. So it did send out the buy, filled it, accepted, blah, 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 warning. Okay, some message from Dukascopy, but there seems to be orders there now. Okay, so you can see here is it's still collecting ticks from Dukascopy on the Euro USD. In this case, I'm going to put on the queue close. So there you go. So something happened here. So we'll continue collecting queues, but let's just check out what this was. So you can see here when we do a close, market sent, order is from a local computer. So we do a sell, and then it closes out that position. So sell, and then I think we've completed everything, and that should be global lock on file. So it looks like there's some kind of log file. Not sure what causes this, but again, I'm new at it. But the point is that here we did a sell or a close on an order up here. That was when we put a buy position in. I believe that's how it should work. Now, so far that's what I'm assuming, and that should be all driven through Redis. So here what we can do is on our Python scripts we can push those order and closes and modify the order or whatever we want through the Python script and expand this list here on top of being able to identify each order. Hopefully this will help you out.